Cool.
Hi, everybody. Welcome to our next presentation. Next up, we have an introduction to artificial intelligence presented by Gordon Tang and the Carleton AI Society. So I'm going to pass it off to Gordon.
Hi, thank you, Matthew. Hi, my name is Gordon Tang. I am the co-president of Carleton Artificial Intelligence Society. And today I'll be presenting an intro to AI. And it's mainly basing off Comp 3106, which has the same name. Cool. So before I begin, I just want to do a quick overview of undergraduate AI at Carleton. So at the moment, in early 2022, there is no AI and ML stream yet, but it's likely to come in fall 2022. And we know this because from multiple reliable sources. And next. So currently, the AI courses at Carleton include computer vision, machine learning, neural networks, intro to AI, and maybe 4900, which is a special course. And historically, there has been intro to surgical data science. And if you're a fourth year, you're able to take graduate courses as well. And you have more access to AI courses there, such as intro to data science, geomatics, probably. Cool. So before you take these fourth year and third year courses, you have to do prerequisites, and it's just linear algebra 1104 and some 2x computer science courses, like second year, like 2404 and 2402. So what's interesting here is that you don't have to take second year like linear algebra 2. I think it's not 1107, but you just need one linear algebra course that everyone's required to take anyway. So yeah, so I'll just jump straight into what we covered in Intro to AI. So it's broken down into 4 topics. The first one is agents and search. The second one's Bayesian rules. The third is reinforcement learning and language. Fourth one is neural networks. And fifth one's the final project. So what's interesting here is that neural networks wasn't really a component in itself because there's a fourth year version of the course. So it's an extra credit component, and we only had one class on it, just so we have an idea of what it is before we take the fourth year version. And cool. Actually, so before I jump into each of these topics and kind of give a high level explanation on what these are, I want to talk about the final projects first because it's the most interesting. So the requirement for last semester, at least, was to make a project that is anything AI related. And it's extremely flexible as long as you can convince the grader, which is the TA, on what techniques you used, AI techniques. So for my group, we decided to make a snake AI agent. And because we had 3 people, we each did one model. These are Q-learning, deep Q-learning, and A-star search. So I explained a little bit more on what Q-learning is and deep Q-learning and A-star search as well. Now, unfortunately, I can't play video, but it was a video of my A-star search implementation. So A-star search, you probably have heard of it somewhere in an algorithm course. It is a shortest path algorithm that is really fast because it has a heuristic function. So, but it's not important. It's the shortest path algorithm. So basically, you start at the head, you have the source, and you're just trying to find the shortest path from the head to the source. And it works pretty well. As you can see, the score is 95. And for comparison, a human benchmark is around score 20, which is a lot lower. But you can also see the limitations of this approach. Because it's so naive, it's always calculating the shortest path. It won't take future actions into consideration. So if you had a bad sequence of red, so a human player would probably take a long circular path around the outside just to give yourself space. But because this agent takes the shortest path, it might dig itself into a grave very fast. And that's in fact what happened in this video, but I can't show it, unfortunately. Cool, so I'll just dive right into the first topic, agents in search. So most AI problems can be described as graph problems, and powerful graph search algorithms exist. So you probably heard of graph from Comp 1805. They're just nodes and vertices connected by edges. So examples of really powerful algorithms would be A-star search, shortest path from 2 points, and others like minimax search, which is really useful for adversarial games. Adversarial just means zero-sum game, which just means if you play a game, there can only be one winner. So there's one winner and one loser. So an example of it would be tic-tac-toe. Chess is an adversarial game. Go is also an adversarial game. So for these types of games, you could perform minimax search, which basically brute force every single possible combination you could have, because you have two players. Each player is assumed to be rational, so they take the most optimal move. And there has to be an end state because a player has to win in this game. So you just make a giant search tree, and a minimax with alpha beta pruning just searches it a little bit faster. And you just try to estimate what your best move will be. Cool. Hope that made sense. So the second topic is Bayesian rules. So you probably heard of Bayes from a stat class like Stat 2507. And in AI, it's used a lot as a naive Bayes classifier, as a very quick benchmark to test a classifier algorithm before you jump into more complicated models like in machine learning. So the benefit of naive Bayes classifier is that it's simple, fast, and works pretty well, but it's a bad estimator. So it's pretty complicated in my opinion, but the gist is that it calculates the most likely hypothesis, which is your answer given evidence, which is the data you receive, and uses Bayes' rule, which is P of A given B is P of B given A times P of A. No, you can look it up. So the second thing you can do with Bayesian is to build a Bayesian network, which is just directed acyclic graphs of cause and effects. Cool, and it helps you calculate the probability of an event occurring. And the third one is a fuzzy search, which unlike the other two methods, this one is an estimate because you might not always have perfect information, like in Bayesian network. You need someone who's very knowledgeable in the area to give you a graph that would accurately represent your problem statement. But in fuzzy search, you can use probability to find out what the most likely event will be in the future. Cool. So the third topic is reinforcement learning and language. So this is actually two separate topics squished into one. Reinforcement learning and language are different. So I'll mostly be talk about both. So reinforcement learning, as I explained in my third slide, there's something called Q learning and deep Q learning. So the Q learning is based on the Bellman equation. It's a very famous equation you see a lot even today. I'll just quickly go over what the basis of reinforcement learning is. So in reinforcement learning, you want to train an agent with a reward function. And a reward function would be like, if you did something well, that will, whatever you define that to be, I'll give you +1. And if you did something bad, I'll give you -1. So Bellman equation takes this idea and moves it one step further. Not only does it train the value function, it trains the Q value function. So the Q value is just a state and action versus just a value. And so it uses the reward function to update the state and action pair. Cool. I guess it's not like super clear what a state and action is. So I guess if we go back a little bit, for tic-tac-toe, let's say, a state would be the board state. So you have the 3 grid and whatever positions of the crosses and circles are. And the actions would be the possible actions you can take at that certain state. So let's say the board is empty right now. You're the first to make a move. All the possible actions would be a circle on each of the grid. So there are 9 possibilities there. And so assuming you have so empty board as a state and your 9 actions, you got 9 state action pairs right now. And then you just play the game. And depending on the end result of the game, you would know if it should be a reward or a punishment, and you'd update the state and action accordingly. Cool. Right, so in reinforcement learning, there's this really important concept called exploration and exploitation. So what this means is that, so what I explained just now with how the person takes the highest Q value, so that would be exploitation because you're taking the best action that you know currently. But because this is the best action is not always the best action, because you haven't played all possibilities yet, maybe, or the map is just not in your favor. So a quick example would be, let's say you have 2 paths, and I shouldn't just wing it. All right. You could look it up. So bag of words model. A bag of words model is an NLP technique, and it sounds really fancy. It's actually used in research, but all it does is just count the number of words it appears in a document, and it puts it into a vector. So it literally says, let's say in this slide, reinforcement learning and language, there would be a vector reinforcement for position 1, learning position 2, and position 3, and language position 4, and it'd just be 1, 1, 1, 1. And you have a different document without these words, it'd be 0, 0, 0, 0. And you could do some stuff with it. So you could begin to visualize a document in terms of matrices. So you could do math on it, one representation of language. Cool. So the last topic is neural networks. So a really a 1-minute overview of neural networks is that it's a state of art in computer vision, medical imaging, and NLP. It is biologically inspired from neurons. So this is also called artificial neural networks sometimes, because they're just artificial neurons. And what it is, it just takes an input layer, has a bunch of connections in the middle, and an output layer. And you just feed it a whole bunch of data. And for each data, it goes through the model. It gets there's a score generated at the end from the output layer. And you just update weights by back propagating. And eventually, through many, many iterations, it becomes really good at classifying. Cool. Yeah, so the benefit of a neural network is that it has really good prediction capabilities but it lacks explainability. So it's often called the black box because it's just a bunch of neurons connected to each other. There has been a lot of work in explaining neural networks right now. So I just went to my neural networks class, and one way that they try to understand what's happening inside is that they give very specific images to try excite neurons, and depends on which neurons get activated, they can know what that neuron represents. Cool. Yeah, but if you're interested in learning more, the Carleton Artificial Intelligence Society is hosting a neural network series that is very beginner friendly. First workshop was last week. There's another one this week and the week after. And it's all recorded on YouTube, but we do encourage you to come in person. It's usually Wednesday at 6 p.m. So make sure keep that spot free. You can ask questions from people who actually know what neural networks are. Cool. Because there are no questions in chat, I'll just jump straight to the end. Socials and Q&A. So like I said, Carleton Artificial Intelligence Society is doing a lot of things this semester. So one of our exciting events is the Artificial Intelligence Society Case X competition with a $250 prize pool. This is a supervised machine learning competition, and it's very beginner friendly. And if you need help getting started, we have workshops from last semester that's supposed to help you in this competition, but you could also look things up online. It's pretty easy. I think it's very introductory. Cool. So we also have podcasts, and we currently have 4 guest speakers on there, and we're working on getting more. There's a link for your reference. And right, we have hands-on projects this semester. So right now we're doing neural networks for 3 workshops, but once we're done with neural networks, we'll make a computer vision project, and you can put it on your resume, and PyTorch and computer vision. Cool.
Awesome. Thank you so much, Gordon. There aren't any questions in chat, but I love AI quite a lot, and so I have some of my own that we can chat about for a few minutes here. And so I think one of the things that I'm wondering about, and I mean, I've experienced this a little bit, but you've talked about a lot of classical AI methods here. And then you've also sort of gone over what like neural networks and stuff like that, like machine learning models and stuff look like. But coming back to like classical AI, what types of projects would you recommend to students who want to sort of explore some of these ideas? Yeah, so we see here we have A-star, Minimax. How can you explore some ideas, these ideas, before you can maybe take the course in computer science?
Oh, that's really interesting. That you even differentiate between classical methods and like deep neural network methods, because I always had the assumption that AI is all deep neural networks, but it turns out that most AI is not deep neural networks. So if you want to experience a bit on classical techniques, the naive Bayes classifier, there's a lot of examples on it. Minimax search, you could build really cool game agents for tic-tac-toe. There's a YouTube series from Coding Train. I highly recommend it. He built a tic-tac-toe Minimax search on JavaScript. So it runs on the web, so you can actually see it. And it's really cool. And A-star search, you'll see more of it in 3804. So look forward to it.
Nice. And I can definitely say the Coding Chain is a great YouTube channel with so much amazing content. And so that's definitely one that I would recommend as well. And now I'm also wondering, once we talk about like applications of sort of theory when it comes to AI, a lot of the times what we'll think of now is maybe the AI that we use when we're using like our maybe Alexas, or when we're interacting with stuff on the internet, maybe the AI behind YouTube's video algorithm or something. And so when it comes to maybe classical AI versus some like either reinforcement learning or and any like neural networks, what are some like interesting use cases you can see in like the next several years that like might get people excited to study this?
Interesting. So right now, I'd say the most cutting edge, most research would be either neural networks or natural language processing. I can't elaborate too much on it, but I heard there's a lot of potential with AI and health because they need help. Let's say you have an X-ray scan of your chest. They need doctors need some assistance in just identifying tumors, for example. That's something neural networks can be really good at because it can classify things very well. But there would be some downsides there too because your camera has to be very consistent. If you have a different input, the size is slightly different, it might give you some problems.
Yeah. Okay. Yeah. So I think definitely. I've taken the third year course. Well, I guess it's now a third year course. It used to be a fourth year course, like the AI course. And I haven't gone too deep into neural networks, but since I do a lot of game development, I see a lot of overlap where classical AI is used a lot of the time. And do you see any spaces in which, like historically, I mean, this is like a very broad answer. I'm kind of just like podcasting at this point, but do you see any places where classical AI is likely to be taken over by more neural network options in like the near future?
Okay, that's a really interesting question. So recently, I've watched a podcast from Lex Friedman with Tesla, Elon Musk.
Yeah.
And it really shocked me that Tesla's strategy to solving self-driving is to use as little neural networks as possible. Whereas there's a competition called the one from George Hotz. Do you know what the name?
I don't know what the competition. It's like is that like the drive a certain amount, or like you have to like find the speed of the car or something like
Is
that?
It Open Pilot?
It's not OpenAI. It's so. I'll think about it in a few seconds.
Yeah.
I listen to a lot
It's
of George
George Hotz. He's the creator. Oh, Comma AI.
Comma AI. Yes. There we go.
Yeah, it's the Android to Tesla. So what he does is he just uses a lot of neural networks, self-training, lots of tests. So that's like a competition between Tesla and Comma AI, and I find that really interesting.
Yeah, and I would definitely also recommend listening to the Lex Friedman podcast with George Hotz because that's like a super interesting one as well. But also Lex Friedman, great podcast. One question we have in chat here: do I have to learn CNN, so convolutional neural networks, before doing some machine learning stuff?
So CNNs are good for computer vision. So if that's kind of the path you want to learn more, then for sure you need to learn about CNNs. But that's not necessarily true. CNNs are like these like advanced deep neural network techniques. There's a lot of classical techniques in computer vision as well in OpenCV. And that's something I'm actually learning in school right now, just to use OpenCV.
Is that for the computer vision course that you're taking?
Yeah.
Nice. Yeah, I took that one. I think I like that one a lot because there's such like you really see how linear algebra plays such a good part in like we're as we're analyzing images, what are techniques that we can use to break down the images into simpler forms. And so maybe running what's called like a convolution over the image, and so you just get borders, and then it's a lot easier to work with borders than it is like a full image. And so there's some, and I mean that crosses over a lot into like image processing as well. And so these research fields are like super close, and it's really interesting to kind of see where they overlap. Another question, are there any upcoming workshops from the Carleton AI Society?
Yeah, for sure. So like I said, we're currently having a neural network series. It's a 3-part series. We just had the first one last week. So you aren't too late in joining if you joined this week. So this week we're doing a hands-on series. And what's really nice about just doing AI in today's world, I feel, is that like big companies like Google and Facebook are just spending a lot of money and open sourcing everything they do. So you can have access to really high-end GPUs for free with just your Google account. It's pretty nice.
Awesome. Yeah, so I think that's about it for what we have. So Gordon, thank you so much for this talk on AI. Super cool subject. It's awesome to see that we have a lot of stuff happening at Carleton in sort of this field. So if people are interested in it, they can definitely study it as maybe a stream in the future. And so thank you so much, Gordon. Definitely check out the Carleton AI Society, and we will be back in just a few minutes for our next talk, an introduction to collaborative filtering.
All right, see you.